We are picking up some few of the special cases when it comes to elastic collision in one dimension. So we're looking at what happens. We start off with case when the masses that collide and its elastic collision, they're equal. So M1 is equal to M2. We have seen this in terms of videos actually. Or let me take up the derivation, then move on. So V2 as per equation, this above equation will be equal to U2. This will be 0, right? Plus 2 times of M times of U1 divided by M1 plus M2 will be 2M. So this and this will get cancelled. So basically we'll end up with V2 is equal to U1. Okay. Similarly, we can prove V1 will be equal to U2. So what can you tell from the above this two equation? Yes, the velocities will get exchanged. Velocities get exchanged after collision. Okay, let me put it in this way. You have object 1, you have object 2. This is, so both are of the same, mass, right? So basically we have the same object. Say this is with 10 meter per second and this is with 4 meter per second. So this is before collision, and after collision, this becomes 10 and this becomes 4. Okay, so this is before and this is after. You can see that this is A and this is B. This will be A and this will be B, and their masses are the same. So this is, say, 2 kg. This also is 2 kg. And they had a elastic collision. Right, so let me put across a video. We have seen this video. So this is the closest I have to elastic collision. So now the masses, clearly they are the same, same ball bearing and everything. Similar ball bearing and everything. So the first has some velocity, the other has 0. So whatever the first came in, same rate the last went out. The first became 0. The velocity of the first after collision became 0. And the last went with the velocity with which the first came in. Okay, again, my language. If you're not able to understand, you can just watch the video. Right, that's it. So that is your first special case. Then we have few more. Remember, all this has to do with elastic collision. So when light body collides against, this is an important result actually, massive stationary body. Okay, so basically we'll consider M2 is much greater than M1. This means much greater. And one more thing is, the second object is not moving. It's at rest. So from V1, if I substitute, let me go to it. So if I substitute, you have V1 is equal to U1, okay, times M1 minus M2 divided by M1 plus M2. Yep, we need to memorize this formula. And you have U2, right? That is the other expression will be U2. Again, remember, this is for V1. So we're looking at expression for V1, not V2. So here U2 is 0. So I need not write the second term. This is 0 basically. See, as m1 is much greater than, sorry, m2 is much greater than m1, m1 minus m2 can be approximated to minus m2. You guys agree? It's like subtracting 0.0001 with 1000. So 0.001 minus 1000 is minus 1000 itself. So this is a very big value. So the answer is approximately minus m2. Therefore, v1 will be equal to u1 times of minus m2, and also in the denominator, when I add a small value to a very large value, it will give me this itself. So this and this minus 1. So v1 will be equal to minus u1. So what does this imply? This implies light body rebounces with same magnitude of velocity but in opposite direction. So basically it bounces off. That's what it means. Basically it bounces off. Okay guys, so an object which, if it goes, okay, let me give an example. You have basically consider a wall, so object goes with say 10 meter per second. So this is before, and now let me show the after, or let me actually make a, I'm not very happy with that. Let me take up a square object, and yeah. So this is before, and now this is after. So what happens? It flips. That's it. Okay, this and this. Right? So what else do we have to do? I think, okay, there's one more. When a massive, oh yeah, this is basically you bouncing off a ball against the wall, right? You throw a ball against the wall, it comes back. So we're just looking at that. When a massive body collides against a light stationary object. So let's see what happens. So we are here, we are looking at m1 is much greater than m2. Remember, m1 is the one which is chasing m2, right? Okay, and you have u2 to be stationary. Light stationary object, right? u2 is stationary. So let's look at v1. So v1 will be u1 times of m1 minus m2 divided by m1 plus m2. And this is plus u2 times of something. So this is 0 basically. And similar to what we did before, this will be m1, this also will be m1, right? Approximation. So this will be v1 is equal to u1. So basically the object, the massive object's velocity will not change, right? This implies massive. It's like a train hitting a bug. When there's a fly in front of a train and train is moving, so it will not matter to the train. So massive object continues to move with same velocity. Right, then we have V2. Sorry, this is the continuation of the same thing. Let's see what happens to V2. V2 will be, this will be 0 plus 2 times of M1 divided by M1 plus M2. Again, you need to know the main formula, and this is U1. So this M1 and approximately this is also M1. So this will be 1. So basically V2 will be 2 times of U1. So the object, second object, will fly off with double the velocity of whichever hits. Okay, so basically let me take a train. And you have a ball, I guess, in the air for a second. You threw a ball in front of a train, right? And this is moving with the velocity of, say, 60 kilometers per hour. So all this is before. And we have after. So after, no, that will continue after the collision, you know. So this goes flying off. Say this is a drone or something, you know, stationary over there, right, in the middle of the air. So this will go flying at 120 kilometers per hour. Again, remember, this is perfectly elastic collision. You need to understand that this is perfectly elastic collision. So this is before and that's after. I think we are done with the cases. Yeah, perfect. Okay, so please copy all of this and you have to remember the result. And this is to do with elastic. Don't get confused with inelastic and don't apply it over there. That's a general mistake people make.